Hi there. What we're going to do right now is we're going to study the properties of exponents and simplify some problems. So first of all, when we have two bases that are the same and they are being multiplied, what we have to do is we have to add their exponents. Okay, so for example, a to the fifth times a to the second, you would just add 5 and 2 and you would get a to the 7th. When we're dividing, we subtract. So if we had a to the 5th divided by a to the 2nd, we would subtract. 5 is bigger than 2, so 5 minus 2 gives us a to the 3rd in the numerator. Okay, power to a power. So when we have something, a base raised to an exponent that is then raised to an exponent, we multiply. So for example, if we had a to the 5th squared, we would keep our a, and 5 times 2 gives us 10. Okay, power of a product, we just have to make sure that each of the values inside those parentheses being raised to the exponent are raised to the exponent. So for example, if we had something like a b to the 3rd, we can rewrite that as a to the 3rd, b to the 3rd. Same thing goes when we have division. Okay, this fraction is being raised to the m power, so that means both the numerator and denominator get raised to the m power. Okay, so to throw some numbers in here, if we had a divided by b to the 3rd, we could do a little rewrite that says a to the 3rd, b to the 3rd. Okay? If the exponent was negative, what we can do is write the reciprocal of this fraction and make that exponent positive, and then use the rule that we just used. And another little property that comes in handy is that anything raised to the 0 power is 1. Okay, so let's do some practice here. So I have 9 problems for us to work on. And what you might want to do is you might want to just stop the video, go ahead and try them, and then I'm going to work through them. So you can go ahead and stop the video. Okay, try these 6 problems, and then I'm going to work through them. If not, just keep going with me. So we have s to the 3rd times s to the 4th times s to the 1st. Because we are multiplying and we have the same base, we are going to keep that base and then add 3 plus 4 plus 1, which is 8. That's our answer. For number 2, very similar because we have all multiplication, but what we're going to do is we're going to look at the two u to the 8th and u to the 5th. So 8 plus 5 gives us 13. And then we have m squared and m to the 7th. That gives us m to the 2 plus 7, which is 9 power. And that's simplified as much as we can simplify. Okay, our quotient property says that we should subtract our exponents. So what I like to do is, these are written in the same order, so it's kind of nice. I say m to the 8th and m to the 3rd. M to the 8th is more, so I know that I'm going to have m left in the numerator. Now, 8 minus 3 gives us m to the 5th. E to the 5th over e to the 6th. Well, the exponent in the denominator is larger, so I know that I'll have e left in my denominator. And now I do 6 minus 5, which is 1. And of course, you don't have to put that 1 there, but I just wanted to make the point of it. And the same thing goes for r. The exponent in the denominator is larger, so I put the r down there, I put the base down there, and then 3 minus 1 is 2. That's our answer. Okay, a problem like number 4, very, very similar. What I want you to notice is that there's nothing to simplify the f with, so I'm going to leave the f to the negative 3rd where it is for the time being. I have u to the fourth over u squared, which means I have a u in the numerator. 4 minus 2 is 2. And then there's nothing to simplify the n with, so I'm left with n to the negative fifth in the denominator. This is close to the right answer, but it's not in the right form, because when these problems are simplified, when these expressions are simplified, we should not have any negative exponents. So what we're going to do is we're going to take f to the negative third, and we're going to drop it to the denominator so we can make it f to the positive third. Okay? The sign of the exponent changes if you move it from the numerator to the denominator or the denominator to the numerator. So u squared, that's positive. We're not going to move it. We've got a positive exponent, so we keep it where it is. But we have n to the negative fifth, and that is in our denominator. So we will move it up and make it n to the positive fifth. And now our answer is simplified. Okay? On number 5, very similar, kind of combines the last couple of problems. What I would look at is, I wouldn't move anything around yet. I would make my fraction bar, and I would start off with, okay, I have t to the negative 2 and t to the 4th. Well, 4 is bigger than negative 2, so I know that my t's will be left in my denominator. And I'm now going to do 4 minus negative 2, which really becomes 4 plus 2. So I have t to the 6th power. Then I have m to the 4th over m to the 1st. Okay, obviously the exponent of 4 is larger. 4 minus 1 is 3. And the next part always gets people, because a lot of times people think, oh, I can cancel those out. But these are not exactly the same. We know that 6 is larger than negative 6, so I will have e in the numerator, and then I'm going to do 6 minus negative 6. Turns into plus a positive, and that gives me e to the 12th. That is our final answer. Okay. Problem number 6. This is a power to a power problem. Okay, it's also going to use this property. Okay, power of a product. Okay, so it's kind of combining power of a product and power of a power. So what we have to say is we have to take this 4 and make sure every value inside the parentheses, every part of that monomial, is going to be raised to the 4th. So we have 3 to the 4th, c to the 5th to the 4th, a to the 4th to the 4th, and t to the 1st to the 4th. Okay? And what we have to do now is we have to multiply. First of all, 3 to the 4th means 3 times 3 times 3 times 3. That is 81. Now what we have is a power of a power. So we multiply these and we get c to the 20th. A to the 4 times 4 gives us a to the 16th. And t to the 1 times 4 gives us t to the 4th power. Okay, so that used a couple of different rules there. 7 and 8, you should notice they look very much alike. The only thing that is different is that the 2 is inside the parentheses here, and it is outside the parentheses here. So here, the 2 will be raised to the 4th, and the a to the 5th will be raised to the 4th. And now we'll clean it up. 2 times 2 is 4, times 2 is 8, times 2 is 16. We get 16 times a to the 20th. For number 8, we don't raise the 2 to the 4th, and now we have a to the 5th, to the 4th. We multiply because we have a power to a power, and we get a to the 20th. Very similar for number 9. We have division inside of the parentheses, so I'm going to write it out. We are going to have everything being raised to the 3rd power. I might not need to write all of this out at this point, but I'm going to. And now we will clean it up. 4 times 4 times 4 is 64. B to the 5th to the 3rd gives us B to, we multiply those, we get B to the 15th. 3 times 3 times 3 is 27. It's known as a cube, just as 64 is. And then C to the 3rd. So hopefully this tutorial helped you with your properties of